Alright, so these are the exercises of this new booklet, which is function, and that's all. So first question is, if A contains 10 elements, then the total number of functions defined from A to A is, oh, so it's from A to A. So you got something like 10 elements, say 1 2 3 all the way till 10, and then you want to get this mapped to this set 1 2 3 all the way till 10, and we want to find the total number of functions. So a function is basically kind of mapping where each arrow starts from an element, a unique element of this set, and ends at some other element of this set. Okay, it does not necessarily need to be unique, right, for this set. Okay, cool. So for this function, sorry, for this first element, you have 10 choices over here, right? These 10 choices. So this is going to be 10 ways for that arrow to be. Then for this element 2, you have 10 choices, and then once again 10 choices, and so on till this element. So you're going to have 10 choices, and that's going to be 10 power 10. Okay, so these many functions are going to be there. Nice. Next question. If f of x equals to x minus mod of x upon mod of x, then f of minus 1 is, so just put minus 1 into that. So f of minus 1 is minus 1 minus of mod of negative 1 upon negative 1, the mod of that. So the mod of negative 1 is just positive 1, so minus 1 upon minus 1, that should be 2. So yeah, that was an easy one. Oh shit, sorry, this is not 2, this is negative 2, because this should also be 1, so it's negative 2 and not 2. Next question. If f of y equal to log y, then f of y plus f of 1 upon y is, alright, so yeah, that's going to be 0, because log of y plus log of 1 upon y is like log of y minus log of y, right? Because log of y to the power of negative 1, that's the same as negative log of y, right? And that's why this is going to be 0, and that's only when y is positive, because if it's not positive, then this thing is not defined. So this is 0. Next question. If f of x equals to log of 1 plus x upon 1 minus x, but that is in the integer function. Is that the integer function? I don't think so, because that's not specified, so not necessarily an integer function. So we just want to find f of 2x upon 1 plus x squared. Okay, so let's just put that into this function. So f of 2x upon 1 plus x squared, I don't think these are integer functions. Okay, cool. So this is going to be log of 1 plus this thing, so 1 plus 2x upon 1 plus x squared upon 1 minus 2x upon 1 plus x squared. And guess what, 1 plus x squared is defined all the time, and it's always positive. So this thing is just going to be log of 1 plus 2x plus x squared upon 1 minus 2x plus x squared, which is log of 1 plus x squared upon 1 minus x squared. Okay, that's nice. And yeah, I can write this thing as 2 times the log of mod of 1 plus x upon 1 minus x. That's nice. Is this always going to be a positive quantity? No, not necessarily. This can in fact also be a negative quantity, right? For example, say x equal to minus 2, then this inside is going to be a negative quantity. So you do need that log of mod of that thing for it to be defined. Anyway, so where were we? So this is oh, that's nice. So yeah, this is just 2 times of f of x. Wait, no, not necessarily. Right, so if this quantity is like positive or something, then this is, yeah. Okay, so because they have defined f of x to be this thing, we are assuming that this is obviously going to be a defined quantity. So yes, it's just 2 times of f of x. Okay, next question. If f of x equals to cosine of pi squared times x, okay, plus cosine of negative pi squared times x, then, oh, well, that is weird. Is that like cosine of pi squared and that thing times x, or is it cosine of pi squared x? I think this is cosine of pi squared times x. Well, yeah, so okay, That is very weird. This is just going to be like 2 cosine of pi squared and that thing times x. So f of pi by 4 is okay. I don't know. uh what do they mean by this thing? What is this? They should have given more brackets first of all. So your options are f of pi by 4 is 2. I'm not sure. I'm really not sure. F of negative pi is 2. So once again I'm not sure. F of pi is 1. Just how is this happening? How? Wait, is this actually the greatest integer function? Okay, this could be. I mean, it could be the greatest integer function over here. So pi squared is like 3.14 squared. Okay, let's just do it like this. So pi is between 3. It's between 4 and 3. So like pi squared is between 16 and 9. Okay, that's a big range. That's not what we want. Maybe 3.14 squared would be a better thing. So 3.14, 3.14. You get 56 and 12 and 0 and oh god, this is frustrating. And then 31400, then 42 9. So it's just like 6 9 5. Wait, what? I cannot believe I suck at this. Okay, 94200. Where did that come from? Is that correct? Yeah, I guess that's correct. So then 4 is 8. Got 9. Yeah, it should be correct. Okay, nice. So yeah, nice. So how many points? 4 points. 1 2 3 4. So it's like 9.85. Okay, but we know it's going to be 9.41 something. So maybe let's just do 3.15 squared. So 3.15. If this turns out to be something bigger than 10, then we might have to worry, because we want to find the integer. Is this really even the integer in the first place? This is very weird. I think they mean the integer, but just find it. So this is going to be what is it, like 1575, then 0 31500. Then you got 45 and 9. So this has to be 0 2 1 carried on. This is 2 1 carried on also. So like 5, and then this is 9 9. So yeah, this is also something which is less than 10. So in the end it's just going to be like 9.9, approximately 9.9. Okay, so pi squared is like approximately 9.9, which means that the integer of pi squared, which is the greatest integer function, that should be 9, and the greatest integer function of negative pi squared is like negative 9.9 something. Okay, maybe 9.8 something, I don't know. So that is going to be negative 10, I think. Yes. So this is really like cosine of 9x. I don't know. Cosine of 9x plus cosine of minus 10x. This is very weird. So then cosine of pi by 4 and pi by 2 and all this stuff is okay. So cosine of pi by 4 times, if I put pi by 2 in that, so this thing is just going to be 9 pi by 2, and we know that at pi by 2 and all odd multiples it's 0. And this is going to be cosine of 5 pi. Yeah, so 5 pi is like, okay, this is 0, this is pi, this is like 2 pi, this is 4 pi, and this is 5 pi, so it's negative 1. So yes, this is correct. At least they should have mentioned that this is the greatest integer function, because otherwise it just doesn't make sense, right? So is and also, is this a multiple choice? Okay, they have given us nothing. We don't know if this is a multiple choice question. We don't know if this this is an integer function or not, or what is this. And C option says f of pi is 1. So when you put no, it's not 1 because this is going to be negative 1 and this is going to be like, yeah, this is going to be minus 10 pi. So 10 pi, that thing is 1 and this thing is negative 1, so it's going to be 0. F of negative pi is like f of cosine of 9 pi plus cosine of 10 pi, so no big difference, it's also going to be 0. Pi by 4, so 9 pi, okay, then there's going to be square root 2 and stuff. So this thing is going to be 0 because this is going to be like 5 pi by 2, but this is like 9 pi upon 4, which is 2 pi plus pi by 4. So this is just cosine of pi by 4, which is 1 by square root 2, so that's not 2 at all. So yeah, D is the correct answer. Go to the next question. I hate these kind of questions where they don't give us anything. Next question is, if f is a real to real function satisfies this function. Oh, it's the Cauchy equation. Hey, I know this one. And f of 1 is 7, then summation from I equals to 110. Come on, this is like a really nice thing. So how do I do it? What's the way to be doing it? So I think that thing was like f of n times x is n f of x. Yeah, so it goes like this. If you replace y by x, you get f of 2x as 2 times of f of x. Okay, and if you replace y by 2x, then you should get f of x plus 2x, which is f of x plus f of 2x, but f of 2x is just 2 f of x. So this is f of 3x is 3 f of x, and then this is just going to continue, right? F of 2x is 2 f of x, f of 3x is 3 f of x, f of 4x is 4 f of x, and so on, right? So in general, f of nx is n f of x. So how do we prove that? So assume that this chain thing continues till n minus 1 times x. Yeah, so f of n minus 1 x is n minus 1 into f of x. So let's just assume that that is true, and we did all the cases and we found out that this is true. Okay, so next, f of nx, that is f of n minus 1x plus x, which can be written as f of n minus 1x plus f of x. And yeah, you guessed it, it just turns out to be n times f of x, right? Replacing this thing by that thing. So if this is true till this step, then in the next step 2, it's going to be true. So it's like saying if this is continuing till this point, then in the next stage it's also going to continue. This is called induction basically, so it's not a big deal. So what we are very interested in is this first equation only. We don't need the proof over here. But hey, it's nice. It is something which I learned from the Olympiad. I should say Olympiad preparation. I mean, I kind of failed in that Olympiad, so let it be. Okay, so they have given us f of 1. That's nice. So it's just going to be f of n is n times f of 1. That is very nice, which means f of n is n. Wait, what f of 1 did they give us? Oh, it's 7, so it's 7n. Nice. So now we want the summation from r equals to 1 to n of f of r, which is just going to be 7r. Oh, that's easy. So it's just 7 into n plus 1 into n upon 2. Hey, that was really easy. Nice. Go to the next question. If f of x equal to this thing for x bigger than 2, then f of 11 equals. I don't think that's a big thing, because just put 11 is that. So f of 11, that is going to be 1 upon square root of, oh, this is going to be really bad. Okay, plus 2 square root of, so 22 minus 4, which is 18, and yeah, this is also 18. Okay, so 1 upon square root of 18 is 3 square root 2, I think. So 11 plus 6 square root 2 plus 1 upon square root of 11 minus 6 square root 2. So is this some kind of square format? Maybe we can write 6 square root 2 as 2 into 3 square root 2. Yeah, maybe this is gonna work. So 2 into 3 into square root 2, right? So if I consider 3 plus square root 2 squared, that's going to be 9 plus 2, which is 11, plus, yeah, it's 6 square root 2, so that works. So this square root 2, this square root thing, that is just going to be 3 plus square root 2, and this square root thing is going to be 3 minus square root 2, and now we are good to go. Just cross multiply. So this should be 6 on the top, and then you got 9 minus 2, which is 7. So it's 6 upon 7. Nice. Let's go to the next question. So the next question is, domain of the function 1 upon square root of x squared minus 1 is, okay, so here's the thing, x squared minus 1, this should be, what do we call it, strictly bigger than 0. Yeah, so it is not bigger than or equal to 0 because this is in the denominator, right? I mean, it's in the square root, so it has to be positive or 0, but then it's in the denominator as well, so it has to be positive. So that means x squared is, okay, let's just do it like this, x minus 1 into x plus 1 is bigger than 0. So on the number line, you got minus 1 and 1, you want this region and you want this region. So are there any options? Hey, oh, sorry, it's this 8th question. Okay, minus infinity to minus 1, union 1 to infinity. Yeah, first one. Go to the next question. The domain of the function f of x equal to 1 upon, oh, 1 upon square root of mod x minus x is, okay, so all values of x which are bigger than or equal to 0, those are not good. Those are just going to make this not defined. So we only can choose the negative values in this case. So it's r negative. Hey, that is that's easy. Next question. Find the domain of definition of f of x equal to log base 2 of x plus 3 upon x squared plus 3x plus 2. Right, we can do this. So we just need to make sure that the denominator does not become 0, and at the same time x plus 3 stays positive. So x plus 3 stays positive, that means x is bigger than negative 3. Nice. And x squared plus 3x plus 2 should not be equal to 0, that means x cannot be minus 1 and minus 2, right? So bigger than minus 3, so got minus 3 over here, all the important ones minus 2 minus 1, so it has to be like this, but you don't have minus 2, so it's having holes, right? So it's minus 3 to minus 3 to minus 2, union minus 2 to minus 1, union 1 to infinity. Well, this can also be written as minus 3 to infinity, except these two values, minus 2 and minus 1, which is what they gave us, right? So that's a nice thing. Let's go to the next question. Okay, the domain of the function square root of 2 minus 2x minus x squared, right? No big deal. So it's like square root of negative of x squared plus 2x minus 2. Okay, so x squared plus 2x minus 2, this should be less than or equal to 0. If that happens, then yeah, this is just going to be something which is bigger than or equal to 0, so the square root of that is defined, which means yeah, I think I can do this. X plus 1 squared, x plus 1 squared minus 3 is less than or equal to 0, so like x plus 1 minus, what am I writing? Okay, x plus 1 minus square root 3 into x plus 1 plus square root 3 is less than or equal to 0. So let's draw this. Square root of 3 minus 1, okay, that's the bigger one. This is minus 1 minus square root 3, and this is square root of 3 minus 1. Okay, this is bigger than that, then okay, we want this region. Okay, cool. So it's just yeah, this one, b, right? It's b. Okay, let's go to the next question. The domain of the function f of x equal to x squared minus 6x plus 7 is minus infinity to infinity, then the range of the function is, okay, So domain of this function is all real numbers in the range of this. Oh, this is no big deal, right? Just a quadratic, so it's going to be negative d upon 4a. Yeah, that's the minimum value. The maximum value is infinity, so this infinity, right? So what's d minus b squared is 36 minus 4ac minus 28 upon 4a, which is 4 comma infinity. So that's going to be, okay, what is this? Minus 9 plus 7, yeah, infinity, which is minus 2 to infinity. That's option B. No big deal. So to the next question. The domain of the function square root of x minus x squared plus square root of 4 plus x plus square root of 4 minus x is, right? All the square roots should be defined, that's it. So x minus x squared is bigger than or equal to 0, 4 plus x is bigger than or equal to 0, and 4 minus x is bigger than or equal to 0. Okay, so this tells us x is less than or equal to 4. This tells us x is bigger than or equal to minus 4. This tells us that x into x minus 1 is less than or equal to 0, right? Flip it. That's that means x is in this region 0 to 1. Yeah, so if it is in 0 to 1, these two conditions are automatically satisfied. So this should be the domain, right? Yes, I hope that's correct. Okay, cool. So 0 to 1, there we go. Next question. The domain of the function log of x squared minus 6x plus 6 is, right? So this thing, log of x squared minus 6x plus 6, this should be bigger than or equal to 0, which means, okay, so I assume, okay, yeah, let's just say this is log base 10 or log base e or log to some positive base. So that means x squared minus 6x plus 6 is bigger than or equal to whatever that positive base is raised to the 0th power, which is 1, which means x squared minus 6x plus 5 is bigger than or equal to 0. And guess what, this automatically means that this value has to be bigger than 0, so this is going to be defined. So this means x minus 2, no, wait, 5 and 1, yeah, so x minus 1 into x minus 5 is bigger than or equal to 0. So yeah, I think this is gonna work. Cool. So to the next question. What is this? What is this thing? I don't know. This is obviously incorrect. So to the next question. I think over here maybe they solved for this bigger than or equal to 0. Well, that's not necessary actually, because I mean it is necessary, but that's still quite incomplete, because it also has to be bigger than or equal to 1, right? Next question. The domain of definition of the function y of x given by 3 power x plus 3 power y. Oh, okay, so y of x, here y is the function, and we want the domain of this function, right? So when can we find a solution for this equation 3 power y plus 3 power x equal to 3? This is a weird one. Okay, so maybe like 3 power y minus 3 power x, right? So yeah, so the only thing which we will need is that this should be bigger than 0. That's it. If it's bigger than 0, then we can in fact find what power of y will give us that value. So thanks. That means 3 power x is less than 3, so x is less than 1. This was very easy. So it's negative infinity to 1. Next question. Okay, once again, the domain of this function is, so it's cosine inverse of log base 2x by 2. Okay, cool. Is this, okay, once again, is this thing the greatest integer function or not, or are these just brackets? Why do these people don't define their symbols correctly? Okay, so we will actually do both cases and let's see which one of them gives us the correct answer. Let's do the one where these are the integer functions, the integer function, the greatest integer function. Okay, so That means this greatest integer function of log base 2 of x by 2. This is in this range. It is bigger than, it's less than or equal to 1, and it's bigger than or equal to minus 1. And because this is going to be an integer, there are like only 3 values for this now. So log base 2 of x by 2, this can only be minus 1, 0 or 1. Okay, that's nice. So I guess this thing is going to work. Log base 2 of x by 2 is less than 2, and it's bigger than or equal to minus 1, right? So if it's bigger than or equal to minus 1, the floor, the greatest integer function of that has to be bigger than or equal to minus 1, and if it's less than 2, then yeah, the floor will be less than or equal to 1. So that's nice. So that means if I raise this to the second, if I make these the exponents of 2, so that's going to be 2 to the negative 1 power is 1 by 2 is less than or equal to x by 2, which is less than 2 to the second power 4, which means 1 is less than or equal to x is less than or equal to 8. That's weird. Okay, that's nice. So yeah, I guess this kind of does work. Just less than or equal to 1, right? If it's less than 2, then either the floor function is 1 or it's less than that. So that also works, no problem. It means it has to be less than, it's less than 8. But yeah, as we guessed, this is actually not in this, not in the options, right? So because it's not in the options, we got to go for the next one, which is that this is not the integer function, it's just brackets. Then you got this thing, and this is not correct. And yeah, why am I writing it twice in that case? So let's just do this thing: 2 to that power, 2 to that power, 2 to that power. So 1 upon 2 is less than or equal to x upon 2 is less than or equal to 2. So that means 1 is less than or equal to x is less than or equal to 4. Nice. That's the one which we're looking for. Next question. Next question is, if f of x equal to x squared plus 1, then f of f inverse of 17 and f inverse of negative 3 will be, right? Why did I do that? Okay, so f of x is x squared plus 1. Okay, cool. And we want to find what is f inverse of 17. In other words, we want to find the value of x such that f of x would be 17. So that means x squared plus 1 is 17, which means x squared is 16, which means x is plus or minus 4. So that means f of plus or minus 4, that is 17, which means f inverse. First of all, right, there is no inverse function. So but if we have to define some inverse function, let's just define these on the positive values. So f inverse of 17 is 4. Okay, and we also want this to be minus 3. Hey, that is not nice. How can x squared plus 1 even be what? This doesn't make sense. Minus 3 cannot be the value of f of x at all, because x squared plus 1 is always positive, right? You would get something which is in complex world. So not nice. This is none of these, because first of all, this function it's not an bijection, so we cannot define an inverse for this, right? This is not like a 1-to-1 function, it's a many-to-1 function, so it's not good. And secondly, f inverse of negative 3, when is even x squared plus 1 equal to negative 3? It can never be, right? X squared is always positive. So yeah, this is a nonsense question. Let's go to the next question. Domain of definition of the function f of x equal to 3 upon 4 minus x squared plus log base 2 of x power 5 minus x cube is. right? So yeah, nice. Just do this. So this thing should be defined. That means 4 minus x squared should not be 0. So x cannot be plus or minus 2. Okay. And x power 5 minus x cubed, this should be positive, which means x cubed into x squared minus 1 should be positive, which means x cubed into x minus 1 into x plus 1 should be positive. So like this can be written as x into x squared, right? So if x is not equal to 0, then we can just do this thing. So just plot these things. So it's minus 1, 0 and 1. So over here it's positive, then over here it's negative, positive, negative, right? And it's going to be something like this. Oops, what am I doing? So we just need the positive ones. Right, so it's negative 1 to 0 union 1 to infinity. That's the domain. And it also cannot be 2, so actually plus or minus 2. Well, minus 2 is not in this set, which means we just need to ignore the plus 2 one. I think this is gonna work. So yeah, this is going to work. Nice, which is this option. Next question. Just delete this. Next question is the domain of the function log base 3 plus x. Yeah. Okay. Of x squared minus 1 is now here there's a problem. Like, what if the base of logarithm is negative? We don't exactly know what happens if that happens. So yeah, so we're just gonna stick with the case where the base is positive. So 3 plus x is positive, and also it should not be 1, right? So 3 plus x cannot be 1, because if it's 1 we are doomed. We don't know for what exponent of 1 we are going to get something, right? So that cannot happen. That's going to be either a not defined value or an indeterminate value, right? So 3 plus x is bigger than 0, 3 plus x is not equal to 1, which means like x is not equal to minus 2. Okay, and x has to be bigger than minus 3, and we also need this to be positive. So x minus 1 into x plus 1 should be positive. That means x has to be bigger than 1 or x has to be less than 1. So if x is less than 1, it cannot be minus 2, and if it is bigger than 1, yeah, it is bigger than 1. So minus 3 not included, 2 minus 2 not included, union minus 2 not included, 2 1, right? Oops, it's minus 1 over there. So minus 1, that looks correct, union 1 to infinity. Yeah, that's gonna work. So let's see if that's in the options. Yes, it is in the options. Next question. Domain of the definition of the function. I don't know why they put definition of the function in between. It should just be domain of the function. Or am I wrong? I don't know. Just like it that way. So the function is square root of 2 sine inverse of 2x plus pi by 3 for real values of x's. Okay. So this should be defined. So like 2 sine inverse of 2x plus pi by 3 should be, oh, what was I gonna do? Yeah, this should be bigger than 0, bigger than or equal to 0. So that means sine inverse of 2x is bigger than or equal to pi by 6 minus pi by 6. Ouch. So let's just go for the unit circle. This is like minus pi by 6 over here. Okay, so it should be, this angle should be bigger than that, right? And it is only defined, so sine inverse of 2x has its range from minus pi by 2 to pi by 2. So for this portion only. So x can be any of these things. Sorry, 2x can be any of these things. So sorry, sine inverse of 2x can be any of these things, right? So what can 2x be? So 2x must be some kind of value for sine, right? So what can that value be? So over here sine is the biggest, which is 1, and over here the sine value is the smallest, right? Because the height, the negative height in this case is like the least. Okay, so this is 60 degrees, sorry, 30 degrees, right? Pi by 6, minus 30 degrees. So sine of negative 30 degrees is negative sine 30 degrees, which is negative 1 by 2. So this is negative 1 by 2, and the maximum value is 1, which means 2x has to be less than or equal to 1, and it has to be bigger than or equal to negative 1 by 2, right? In that case, we are just gonna get some value of this sine inverse 2x in this section, right? Nice. So yeah, that means negative 1 by 4 is less than or equal to x is less than or equal to 1 by 2. I hope this works. So negative 1 by 4 to 1 by, oh, it's here. Yes, this does work. Next question. Are these questions too easy? Maybe. The range of f of x equal to cosine x minus sine x is. The range. This is, come on. This is little too easy. So it's like negative square root of 2 square root 2, right? You can either do the what am I saying? You can either do the derivative thing, or just use that fact that the minimum and maximum the minimum and maximum values of this thing, a cosine alpha plus b sine alpha, that thing is minus square root of a square plus b square. That's the minimum value, and the maximum value is square root of a square plus b square. It's kind of a good fact to remember, and yeah, that's nice. Next question. Okay, a few more. Okay, the range of 1 plus x squared upon x squared is, right? So let's just say this is defined. So if this is defined, this is going to be 1 plus 1 upon x squared, right? So the range, so like 1, maybe I can write it like this, which is very very similar to something like this, which has to be bigger than or equal to 1. So this is 1 to infinity, right? As this thing gets very near to 0, this thing goes to infinity. So it's from 1 to infinity, correct? Okay, so this is the correct option. Let's go to the next question. When is this 1? Right, when is this 1? That shit. That's weird. So when is this 1? This is 1 when 1 upon x is 0. Oh no. Oh, that's not nice. So it's actually going to be this thing. Right, have to be careful. Next question. For real values of x, the range of the function 1 upon 2 minus sine 3x is, oh, do we have to do the derivative thing, or is there some other way? 2 minus sine 3x, sine 3x is the same as sine x, right? Maybe we can just do it like that. So we know sine 3x, so for any real value of x, right, sine 3x is less than or equal to 1, it's bigger than or equal to minus 1. So negative sine 3x is less than or equal to 1, it's bigger than or equal to minus 1. So 2 minus sine 3x is less than or equal to 3, it's bigger than or equal to 1. So, and yeah, this is a positive thing, so we can just take the reciprocal. And since we do not have to deal with domains and stuff over here, we can just do this thing. So it's going to be bigger than or equal to 1 by 3 and less than or equal to 1. Yeah, so nice. So this is 1 by 3 to 1. Yeah, right, this is the correct one. Next question. Look at this option, man. This is very bad. 1 by 3 bigger than 1. Wow, that's some nice logic. Next question. Okay, if f of x equal to a cosine of bx plus c plus d, then range of f of x is. Okay, so first of all, yes, the first thing I'm going to do is eliminate these things. Like this is just a cosine of something, say u plus d, because because what am I talking about? Because bx plus c, that is a linear function, so this is a bijection with, right? I don't know what I'm talking about. Once again, bx plus c is a linear function and hence it's a bijection, and so we can just replace bx plus c by u, right? Because the range of this function is from negative infinity to infinity, which is the same as the domain. So yeah, this is a very nice thing. Maybe instead of u, we'll just use x itself. Okay, so a cosine x plus d, that's what we're looking for. What's the range of this function now? So yeah, just do this thing. Cosine x is less than or equal to 1, it's bigger than or equal to -1. A cosine x. Okay, so is a positive or negative? Actually, we don't even care because this is less than or equal to mod a, bigger than or equal to negative mod a. Even if it's negative, this is still going to work. That's nice. So that's going to tell us that a cosine x plus d is less than or equal to mod a plus d. It's bigger than or equal to negative mod a plus d. Oh, there are no mods in the options. So let's just say that a is positive. So this is d minus a and this is d plus a. Right, so d minus a and d plus a. There we go. Correct. And yeah, I am kind of thinking that a could be negative, but let it be. Next question. The range of the function f of x equal to x plus 2 upon mod of x plus 2 is. Oh, okay. So it can be only 3 values. Actually, not 3. It can be only 2 values. It's either -1 or it's 1. Yes. There is also the case when x plus 2 is 0, but at that point it's just not defined. So yeah. Next question. Not defined, indeterminate, maybe indeterminate, I don't know. Next question is the range of f of x equal to secant of pi by 4 cosine squared x. Okay, so x is any real value and you want to find the range of secant of pi by 4 of cosine squared x. Alright, so cosine squared x goes from 0 to 1. So 0 is less than or equal to cosine squared x is less than or equal to 1. So pi by 4, right? So it's going to be something like this. So yeah, we'll just draw this thing. 0 to pi by 4, isn't it? So it's going to be like that. Over here this angle is 0, over here this angle is pi by 4. Over here the cosine value is maximum, it's 1. Over here the cosine value is minimum, right? Because this distance is the minimum and it is cosine of pi by 4, which is 1 by square root 2. And because over here the cosine value is minimum, the sec value is maximum. So it's going to be square root 2 and this is going to be 1. So it's 1 to square root 2. That should be working. Okay, cool. Yeah, that looks fine. Next question. Next question is the range of the function x squared plus 3x plus 1 upon x. Alright, x is a real number is x square plus 3x plus 1 upon. Oh, so first of all, let's just do this thing. So this can be written as 1 plus 2x upon x square plus x plus 1. Okay, so now we just need to find the range of this thing. Maybe like this, 2 upon x plus 1 upon x. Yeah, this could be working. This could be working. So we know the range of this function, right? So x plus 1 upon x has this range. So it's either negative infinity to negative 2, or it's 2 to infinity, which means when you add 1 to that, this is going to be x plus 1 upon x. As this, we could also have equated this thing to y and then formed a quadratic equation and then use the discriminant bigger than or equal to 0 method to get the domain, but let it be. Let's just go with this thing instead. So this thing belongs to negative infinity to right, so just add 1 to that, so it should be negative 1 union 3 to infinity, right? So that's nice, but then you have the reciprocal. This is very bad. Okay, so for this portion, the biggest magnitude is 1, right? So this is going to be like negative 1 2, and the smallest one is, it's 0. I mean it reaches 0, so it's something like this. Okay, that's nice. Actually it can in fact be 0, because just put x equal to 0 over there, right? So it should be something like that. That's nice. So when x is not 0, you can make this transformation, but if x is already 0, then it is 0. So yeah, union. So once again, for this infinity value, this reciprocal is going to be 0. Oh, okay, there's a 2 over there. Okay, just take that 2 out for now. Okay, just take that 2 out for now. So 1 upon this thing, this belongs to this value, this belongs to this set. Oops, what was that again? It was 3, right? So this has to be 1 upon 3, right? And then to the 2 thing, so that is going to tell us negative 2 to 0 union 0 to 2 by 3. And next you have this 1 over there, so just add 1 on every breaking point. So minus 1 to 1 union 1 to 5 by 3. Is that in the options? I don't think it is. Oh, so this thing actually should just be minus 1 to 5 by 3, because why 1 do this thing? So minus 1 to 5. Oh, that is in the options. That's nice. Next question. Next question is function n to n, so natural number solution. Okay, so for the last question they also give these values. So could it be that some of these with at least one of these, minus 1 and 5 by 3, are not actually values which this function can take? I don't know. Let's try it out. So can this function be minus 1? So can x squared plus 3x plus 1 upon x squared plus x plus 1 be equal to minus 1? That means 2x squared plus 4x plus 2 equal to 0, which means x squared plus 2x plus 1. Yes, it can be. Can this thing be 5 by 3? 5 by 3, that means 2x squared, right? 5x minus 6x is minus x, right? 5 minus 3 plus 2 equal to 0. Now what? Can this happen? So what's the discriminant? Discriminant is, oh, discriminant is not good. I don't think this is ever going to happen. Yeah. Oh, it's 9x. Sorry. So this is supposed to be 9x. So 5 minus 9 is 4. This is minus 4. Yes, this is obviously correct. This can in fact happen. This happens at x equal to 1. Right, next question. Function from natural numbers to natural numbers. F of x equal to 3x plus 4 is yeah, so it's a one-to-one function and also an on-to function. It's both a surjection and wait, it's okay. It's from natural numbers to natural. This could be a problematic statement. If it were from real numbers to real numbers, or like real positive to real positive, this would have worked. But it's not. It's from natural numbers to natural numbers. So, let's see. So the domain is 0 to infinity. Actually, I should write the domain in this set form. So 0, 1, 2, and so on. That thing is the domain. And what's the range? So it is obviously a one-to-one function because we get a mapping where it starts off at a unique point and it ends at a unique point, right? So 3x plus 4, like 4 and 7 and 10 and so on. But this is not a surjection because this set is obviously not equal to this set. Wait, was that a surjection? No. The suggestion thing was that the codomain would be completely utilized by the range. But yeah, that's not true because the codomain is the same as domain in this case. So it's definitely not a surjection. Right. So this is a one-to-one but not an on-to function. So one-to-one into no, it's not many ones. So these are correct. Sorry, these are incorrect options, and this is an incorrect option, and this is the correct option. Next question. The function from real numbers to real numbers defined by x into x minus 2 into x minus 3 is. So is this a 1-1 function? No, it's not. Just look at it. It has 3 zeros, which means it can be 0 for 3 values, and thus it's like a many one function. It's not a 1-1 function. Is this an onto function? So is the range of this real numbers? What's the range? What's the range of this? It's a cubic, isn't it? Right, it's a cubic. So every cubic does have its range from negative infinity to infinity, right? These are what cubics generally look like. Okay, why am I even drawing this line? So at negative infinity, this is definitely negative infinity, right? So when x equal to negative infinity, f of x is also negative infinity, and when x equal to infinity, f of x is infinity. So it does have the range. It does have the range equal to this codomain. This is an onto function but not 1-1. Okay. Next question. Find number of surjections from A to B, where A is this set and B is this set. Okay, number of surjections. Surjection means that the range is the codomain. So all of these A, B, C should be utilized, right? So how do we do it then? Okay. We could do this using the inclusion exclusion principle, right? So what's the total number of functions? The total number of functions is 3 power 5 minus the number of functions in which at least one element of this set ABC is not utilized. So there are 3 elements. So it's going to be 3 into, say C is not utilized, then you got 2 power 5, and then plus, if 2 are not utilized, then once again you got 3 ways, right? So one of them must be utilized, so 3 ways. So 3 into 1 power 5, and then yeah, that's it. So this is going to be 3 power 5 is, it's 243 minus, so 3 into 32 is 96 plus 3, which is 246 minus 96, 0, you get 5, 150. There you go. So these are the number of surjections. Okay, next question. If A equal to this set ABC, the natural number of 1 on 2 functions, bijections, which can be defined from A to A is, okay, 1 on 2 functions. Okay, fine. So we got ABC and ABC like this. For A you have 3 of these, so like that. Fine. So let's just say that A is with A, then B has 2, and if these two are already done, then for C there is going to be only one value left. So this is 3 into 2 into 1, right? A has 3 choices. If it goes for one of the choices, then B has 2 choices, and then it's finished because C has to take the last choice. So it's 3 into 2 into 1. And yeah, these are 1 functions, and these are also on 2 functions. That's nice. So this is 6. Cool. Go to the next question. If f is a function from real numbers to real numbers and f of x is mod x, oh, then this function is 1 but not on 2. 1 yeah, it is 1. No, it's not 1 because yeah, so mod of a is the same thing as negative mod of a, so it's definitely not 1. Okay, is this an onto function though? What's the range of mod of x? No, it is r plus, right? I mean r plus and 0 as well. That's the range of mod of x. But what about the negative real numbers, right? So it's not a 1 function, and it's not an onto function as well. So where is it? None of these. 1 but not onto, 1 and onto, none of these, right? Yeah, this is definitely not a 1 function. The graph looks like this. Come on, really, how can it be 1 function, right? And also, how can it be an onto function? Look at these values. These are just not used. It should be going from negative infinity to infinity, but that's not there. Okay, next question. Let f(r)(r) be a function defined by this thing. Then f is 1 onto. Okay, is f and 1 functions. So x1 minus m upon x1 minus n equal to x2 minus m upon x2 minus n. That means x1 x2 minus nx1 minus mx2 plus mn equal to x1 x2 minus nx2 minus mx1 plus mn. So this cancels, so you just get x2 into m minus n is equal to m minus n into x1. So if m is not equal to n, cancel them away, so x2 should be equal to n x1, which means that yes, this is a 1 function. Is this an onto function? So can the range of this function be negative infinity to negative infinity? Okay, that's a weird question. How are we supposed to be doing that? Would this be equal to y maybe? No. Actually, let's do it like this. So x minus n plus n minus n on x minus n. This should be 1. For x minus n being defined, this is 1 plus n minus m upon x minus n, right? This is a linear function, so like this is just 1 plus n minus m into 1 upon something linear, so it's u, right? So u can take all values from negative infinity. Nice. And so can 1 by u, because correct, 1 by u is also kind of a bijection. So that means that this complete thing is also another linear function, which is, yes, it is an onto function at least. So this is yeah, in the end it's just kind of a bijection. Yeah, so this is 1 1 and onto. Next question. The function from real to real defined by e to the power of x is, yeah, so this is not an onto function because it cannot take the negative values, and it is definitely a 1 1 because it's an monotone increasing function. So if e to the x1 equal to e to the x2, then it has to be that x1 equal to x2. Nice. So that means this is 1 1 and into. I don't know why do these people call this into really. Okay, next question. Oh yeah, I think I know, because the code domain. No, I don't know. Let's just move on. A function f from the set of natural numbers to integers. Oh, so it's like n to z. Okay, it's defined by, so it should be something like this. Yes, it's defined by f of n equal to n minus 1 upon 2 if n is odd, and minus n plus 2 upon 2 if n is even. Okay, wow, this is very weird. So is this on 1 on 2? What kind of function is this? I think a good strategy would be just try putting some values. So f of 1 is, so 1 is an odd number, so this is going to be 0. Okay, f of 2 is an even number, so it's minus 2. Then f of 3 is an odd number, so notice this thing is also going to be an even number. I mean, yeah, obviously, because we want integers, so this should be happening all the time. So next you just get 3 minus 1 upon 2, so it's, yeah, it's 2 upon 2, which is 1. And yeah, so the next time it's just going to be increased by 2, right? The numerator is going to be increased by 2, so it's just 1 more than that. So like f 5 is just going to be 2, and so on. So yeah, integers, huh? I don't know. Okay, what about this thing, n plus 2 thing? So f of 4 is, so f of 4 4 is an even number, so use this definition. So 4 plus 2 is 6, 6 upon 2 is 3, so it's just minus 3. And once again, this numerator is just going to be increased by 2 every time, so this complete thing is increased by 1. This negative makes it like decrease by 1 every time, so it's minus 2, minus 3, minus 4, and so on. Here we don't have the value minus 1, which means that no, it is not, it's not a surjection, because the minus 1 thing is missing, so it's like an into function, so it's not onto. Okay, and is this a 1 1 function? Yeah, from the looks of it, yes. So can this happen that n minus 1 upon 2? Okay, this is getting very weird. Maybe I should do it like this. So n is odd, which means like maybe just put 2x plus 1 minus 1 upon 2 is equal to, so n is even over here, so just put 2y plus 2 upon 2. Can this thing ever happen, right? Can it somehow happen that x is equal to y plus 1? Actually, this can happen, right? Yeah, so over here you should be having x bigger than or equal to 0, and over here you should be having y bigger than 0, right? So this thing starts off with 2, so this is like 2, 3, and so on, and this thing starts off with, in fact, this can happen, right? This can happen, or can it not? Okay, you see this function is always decreasing, this function is always increasing, like so no, Oh yeah, so we just missed a negative over there. So it should really be just negative y plus 1. So no, because this thing is always going to be positive, right? And this thing is always positive, so this can never happen. And also these two functions, n minus 1 upon 2 and n plus 2 upon 2, these are increasing functions. So this can also never happen that you will have x minus 1 upon 2 equal to y minus 1 upon 2, where x and y are both odd, or you have minus x plus 2 upon 2 equal to minus y plus 2 upon 2, where these are even. This will also never happen. So yes, it's a one-to-one function. So this is 1 1 but not on 2. Next question: which of the following is an even function? Okay, so is a power x minus 1 upon x e power x plus 1 into x. Wait a second. Sorry. Okay, so this question is, which of the following is an even function? Is tan x an even function? No, it's not. Is this function an even function? It is. Just replace this by, oh no, it's not. It's an odd function, right? So no, this is not correct. This is an odd function. Is this function an even function? So it's gonna be like 1 upon e to the power of x plus 1 upon 1 upon e to the power of x minus 1. If I replace x by minus x, this is like 1 plus a to the x upon 1 minus. No, it's not. It's going to be in the negative of what it was before. So this is not an even function. This must be an even function. Replace x by negative 1. Oh yeah, it's just this thing. And okay, just do this. Negative x, a power negative x is just 1 upon a power x minus 1 upon 1 power 1 upon a power x plus 1. Negative x 1 minus a power x upon plus a power x, which is x into 1 a power x minus 1 upon a power x plus 1. Guess what? Yes, it is an even function. Next question: f of x equal to square root of x power 4 plus 15. Then the graph of the function y equals to x power 4 is symmetrical about. Okay. Oh, charging low. There we go. So this is square root of x power 4 plus 15, isn't it? Right. So okay, yeah, so this is definitely symmetrical about the y-axis because this is an even function. This is not at all symmetrical about the x-axis. So over here it's like an increasing function, something like this maybe. I don't know, just roughly sketching this. So yeah, the y-axis, this is symmetrical about the y-axis. The origin, the line x equals to y. No, the line x equals to y is like that. This is not symmetrical about that line. Okay, cool. Next question: the function f of x equal to log of x plus x squared plus 1. Okay, x plus square root of x squared plus 1 is. So this function is, so this is definitely not an even function, right? This would be very weird. Is this an odd function? Not necessarily. Is this a periodic function? No, none of these, man. So does this necessarily have to be that log of negative x plus square root of x squared plus 1 is equal to log of x plus x square root of x plus 1? No, it's not necessary, right? Just try putting some values. Maybe let's put 2. Yeah, 2 is gonna work. So this is going to be like square root of 5 minus 2, which is obviously not equal to square root of 5 plus 2. This is definitely not an even function. Also, this is not an odd function, right? Or is it? So if this is an odd function, then this should be equal to negative of that, which means if I raise e to these powers, this should be negative x plus square root of x squared plus 1 equal to 1 upon x plus square root of x squared plus 1. So that means square root of x squared plus 1 minus x into square root of x squared plus 1 plus x should be equal to 1. Yes, that is correct. So yeah, this should be an odd function, and that's true whenever these things are positive. Okay, cool. So for the domain of this thing, right? So yes, this is an odd function. Is this a periodic function? No, no. Why would this be? There's obviously no way that this could be periodic. I mean, for all values of x, you got something like, okay, let it be. I just don't want to prove that it is periodic. I mean, we can't prove because it's not. It's visible from this structure itself. Which of the following is an even function? E power x plus 1 upon e power x minus 1. No, we just saw this is actually an odd function. Next, you got, yes, this is an even function. We just did it over here. Okay. And this thing, no, this thing is not an even function. It's an odd function. This is obviously an odd function, sine x. Next question. The function f of x equal to sine of log of x plus square root of x plus 1 is, wow. So we know this inside thing, log of x plus square root of x square plus 1, this thing is kind of an odd function. Yeah, so that means this complete thing is also an odd function because sine is another odd function. So odd function of an odd function, that is obviously an odd function, right? So yes, this is an odd function. Oops, what happened? Cool. Let's go to the next. Is this a periodic function? No, it's not a periodic function. Yeah, I'm pretty sure about that. Because this thing is not a periodic function, so there's no way that this complete thing would be. Okay, so the period of the function 2 cosine x into 2 cosine x of 2 cosine of x minus pi upon 3 plus 3 is. So what's the period of this function? Yeah, correct. This is, yeah, it's x plus 3. The period of cosine x is 2 pi, so cosine of x plus 3 should be 6 pi, right? Yeah. Is there any other option which might be correct? Put 4x in this. Sorry, put 4 pi in this. So no, cosine of 4 pi by 3, that doesn't work, right? It's more like this, 2 cosine of x plus period minus pi upon 3 plus 3 equal to 2 cosine of x minus pi upon 3 plus 3 is like cancels. So this should mean that this equation is true. So that means cosine of x minus pi upon 3 plus b by 3 is cosine of x minus pi by 3 plus b by 3. This is a linear function, so it can take all values, negative infinity to infinity. So oops, what is happening? This is not good. So is this correct? Oops, what is this? This is not supposed to be over there. So is this gonna happen for all values of x and thus like all real values of this thing? Is that so? No, it's not, right? It's not for these values, 4 pi and 2 pi and pi. No. For 6 pi it is. Okay, next question. The function f of x equal to sine of pi x by 2 plus 2 cosine of pi x by 3 minus tan of pi x by 4 is periodic with period. Right, just find the period of this thing. So I think this function has a period of 4, right? So yeah, because 2 pi plus theta, right, sine of 2 pi plus theta is sine of theta. This has a period of, I think, correct, this has a period of 6 pi. So 2 pi, 6 pi, and this has a period of 4 pi. So their LCM, which should be 12 pi, would be like, sorry, this is 2, 6 and 4. So their LCM, which is 12, should be the period, but right? It should be one of the periods. Who told you this would be the fundamental period? No one, right? So let's try making this into a simplified form, maybe. Or maybe let's just try out these three values. So let's put 6 over there first of all. So yeah, so it's just going to be sine of 3 pi plus pi x by 2 plus 2 cosine of 2 pi plus pi x by 3 minus tan of 6 pi. Okay, so it should be 3 by 2 pi plus pi x, which is like, this is sine of, so 2 pi gets cancelled, you just get pi. So pi plus pi, yeah, pi plus theta is just negative sine theta, so negative sine of pi x by 2 plus 2 cosine of pi by 3 is, well, this thing is at least the same as before. And you got this thing. Okay, what do we do with that? So now the real question is sine of pi x by 2 plus, okay, not plus, minus tan of 3 pi by 2 plus pi x. Is this thing equal to sine of pi x by 2? It's negative over there. Minus tan of pi x by 4. This is pi x by 4 over there. Is that correct? That's the question, right? Okay, this is going to be a tough one. So 2 sine of pi x by 2 is tan of, I don't think this is correct. All we need is just an counter example, a counter example, to prove that this is completely wrong. So tan of pi by 4x plus minus tan of 3 pi by 2. What about we put x equal to 0? Tan of 3 pi by 2 is not defined, right? Yeah, so that does mean, I mean, like, obviously 0 is not equal to not defined at all, so that means 6 is obviously not a fundamental period. Can 3 be a fundamental period? Once again, let's just go with the 0 thing. No, this is also not a fundamental period, right? So actually it's not even a period in the first place. Yeah, and neither is 4. Correct, right? So this is very obvious, it's not a fundamental period because it's a period of these two things, but it's not a period of this thing, which means, yeah, this is not not the period which you're looking for. Is this gonna work? So it's a period of that thing, but it's also not the period of this and that. Yeah, so you just need a counter example. So like, just put x equal to 0 maybe. So then this will be like sine of 3 pi by 2 minus tan of 3 pi by 4, isn't it? Right, so it's just sine of, this is just pi minus pi by 4, so this is 3 pi by 2 plus tan of pi by 4, which is 1, plus sine 3 pi by 2 is sine 2 is 70 degrees, so this is going to be, yeah, this is a negative quantity. This is negative 1. This should be 0. Oh, that's not good. Wait, no, that's not nice. It's 0, which is the same thing as that. Could it be that this is actually the period? You know what? Let's try doing this. Sine of, so x plus 3, right? So 3 pi by 2 plus pi x by 2 plus tan of 3 pi by 4 plus pi x by 4. Is this equal to sine of x plus pi by 2. Let's go 4. So can we find a counter example to prove that this is obviously wrong? Let's try putting something like 1 into this. So putting 1, this is going to be tan of pi, and this is going to be tan of pi by 4. So this thing will be like minus 1, and tan of pi is 0. So okay, and this is going to be 3 pi by 2 plus pi by 2. So this is also 0, and oh yeah, this thing is 1. So once again we failed. Let's try something different. Maybe put pi by 2. Sorry, maybe put 1 by 2 for that one. So okay, this could, maybe this can actually work. Yeah. Okay, so first of all, 3 pi by 2 is like 2 pi minus. Okay, calm down. Let's try doing it. 2 sine of 3 pi by 2, 3 pi by 4. Cosine of the addition upon 2. So 3 pi by 4 plus pi x by 2, right? Is this equal to tan of 3 pi by 4 plus pi x by 4 minus tan of that thing? Okay. This is really bad. So it's just tan of 3 pi by 4. I don't know. This could be 3. This just could be, but we just need a counter example, right? Why can't we find a single counter example for this? Try maybe negative 1. Okay. Putting negative 1, we will get sine of pi, which is like 0. Okay. You know what? Maybe the problem is that we have been putting multiples of pi by 2. So maybe that's why we're getting something wrong. Let's try putting an odd multiple of pi by 2. Then this is going to be 0. And at the same time, this is also going to be 0. And putting an odd multiple of pi by 2, basically putting an odd number as the value of x, this thing is going to be, wait, it could be 1 or it could be minus 1. Okay, and this is also going to be something like 1 or minus 1. Alright, so what do we need in that case? 3 pi by 4. Yeah, 3 pi by 2. I think it's negative 1. This thing is also negative 1. Okay, that's not nice. So we need to stop putting multiples of pi by 2 over there. Let's put something like, let's actually put 1 by 2. So we should get something like sine of, actually negative 1 by 2 would be better. So this is 6 pi by 4 minus pi by 4. So just 5 pi by 4. Okay, minus tan of, so it's negative 1 by 2. This is 6 minus 1 is obviously 5 pi by 8. This should be sine of pi by 4 minus tan of pi by 8, which means sine of 5 pi by 4 is like negative, so it's 2 sine of pi by 4 is equal to tan of 5 pi by 8 minus tan of pi by 8. Is that correct? Okay. This is getting really bad. Maybe we can just make it pi by 4 plus 3 pi by 8 maybe. What should I do? Okay, 2 sine of pi by 4. That's square root 2. Okay. What about this quantity though? Their difference is something nice. Their difference is just pi by 2. So tan of pi by 2 is, it's not defined, right? It's, yeah. maybe cot of pi by 2. So cot of pi by 2 is 0, and it is also like cot of pi by, okay, 5 pi by 8 minus pi by 8, right, which is 1 plus tan pi by 8, right? It does not even matter. So yeah, I mean, this thing is not defined in the first place, because 1 plus tan of 5 pi by 8 into tan of pi by 8, that thing is defined. This thing is not defined using that angle formula, and this left hand side is a defined quantity. So yeah, that means obviously this is not correct. This cannot be the period. This was, man, this was a very frustrating question. Okay, next question. In fact, we can just stop for here. 42, how much is oh no, okay, 60, huh? Okay, that's a lot of questions. You know what, let's do it. Let's do all the questions. So it's with period 12. Let's go for the next one. The period of f of x equal to mod of sine 2x is mod of sine 2x. Yeah, so it's pi by 2, right? Sine theta has period 2 pi, but mod of sine theta has period pi. So mod of sine of 2x, that has period pi by 2. So that works. Okay, next question, you have f of x from real to real is an odd periodic function with period 2, then f of 4 equals, oh, so it's an odd periodic function, which means f of minus x equal to minus f of x, and it's an periodic function with period 2, so f of x plus 2 equal to f of x. Okay, and what is f of 4? Okay, and this is from real to real, so one good thing we can do is put 0 in this, so that's gonna give me f of 0 is 0. Nice. And f of 2 is also f of 0, which is 0, and f of 4 is also f of 0, which is, I mean, f of 2, which is f of 0, which is 0. Nice. So A is the correct answer. Let's go to the next question. The period of the function 2 sine squared x plus 1 is, so sine squared x is always positive, so once again it has period pi, right? So yeah, that was easy. It just has period pi. 2 sine squared x plus 1, maybe I've seen this somewhere, right? You do know that 1 minus 2 sine squared x is cosine of 2x, right? So 2 sine squared x is cosine of, so what am I writing? It's just 1 minus cosine x, right? So this is just 2 minus cosine of, means cosine of 2x, so cosine of 2x. Okay, so 2 minus cosine of 2x, it obviously has the period pi. Next question. The period of f of x equal to 1 plus 2x minus mod of 2x if it is periodic is, okay, so first of all, if 2x is positive or equal to 0, oh wait, this is not mod, this is an integer function. Okay. So this is weird. Okay, so this is an integer function. I think this is going to be half. Yes. Okay, so 2x minus integer part of 2x, that's just 1 plus fractional part of 2x, right? So if this is periodic, that's like this is periodic, and yeah, fractional part of 2x is periodic. So what's the fundamental period for this thing? Yeah, it's 1 by 2, because if you replace x by x plus 1 by 2, it just comes out to the same thing. So yeah, it is 1 by 2. Next question. The period of f of x equal to sine of pi x upon n minus 1 plus cosine of pi x upon n. Okay, n is an integer and bigger than 2 is, oh, the period of this thing is, oh, this looks really weird. Okay, so we are just asked the period, but not the fundamental period. So yeah, if they would have asked a period, that maybe would have been better. Let's just find one of the periods and see if this is a multiple of something from the options. Yeah, that will be it. So n minus 1. Okay, so what's the period of this thing? Yeah, it's just 2 into n minus 1. What's the period of this thing? It's just 2 into n. So taking their LCM, the period should be 2n into n minus 1, because n minus 1 and n, these are co-prime all the time. So 2n into n minus 1, that is it. Oh yeah, it's in the options. And no factor of this thing is in the options, so this is really the period. That's it. Next question. If a b be two fixed positive integers such that for all real x, f of a plus x equal to, oh, this thing, okay, and we are two fixed positive integers, all right, fine, this is for real f of x, this is going to be happening, then f of x is a periodic function with period. Okay, so f of a plus x is this quantity, okay, and then we want to find the period of this function. Let me just guess, could it be a? So let's try putting a in this. F of 2a plus x, it's going to be like b plus 1 plus b minus. Right, so you got f of x over here. F of a plus x is yeah, okay, maybe we can just go for induction in that case. Yeah, so we'll just say f of a plus x is f of x. I don't know, we cannot exactly prove this, can we? Okay, this looks more like a recursion. Okay, so let's say this thing is f dash minus b cubed. That thing is 1 plus b cubed minus 3 b squared into f. Maybe I should say f2 and f0, or maybe f2 and f1. Okay, f2 f1, okay, plus 3b f1 squared. Oh, this is just a cube. It's f1 cubed. So this is just 1, what? No, 1 plus b minus f1 cubed. So that means f2 minus b cubed. Oh, this is b over there, okay, plus f1 minus b cubed is b. All right, this is very weird. Okay, how is that periodic? Yeah, so maybe let's just define a new function g of x with these things, f minus b things. Is that going to be a nice, oh, this b is not there actually, sorry, so this b is not there because we got it over there now, so it's not there, and this 1 is in fact there, so this is actually a 1 over there. Okay, so now what? Now what? Yeah, I have no idea. Let's define this new function as g of x. So g of x is just f2 minus b cubed, which means like, okay, f minus b cubed. So g of x plus a plus g of a is 1. Think, is there anything else which we can do? How is this even a periodic function in the first place? So it should be for some period. Okay. And we should also be having g of x plus 2a plus g of x plus a equal to 1. Okay, cool. So if oh, that's nice, that's really nice. Okay, just subtract these two equations. So g of x plus 2a minus g of a is 0. Oh yeah, sorry, this is g of x over there, so it's g of x. That's nice. So with the period 2a, oh, that's really nice. So it has a period 2a, and it could be that the fundamental period is a, but no, not really, not really. I mean, that would be if this and this is like equal or something. This is equal to 1 by 2, which I don't think it is. Okay, next question. Can this be 1 by 2? No, not necessarily. Not necessary. Okay, so this was nice. This was a really nice question. So this has a period 2a. It could be a, but not sure. So yeah, at least one of the periods is 2a. Next question. If from real number to real number f of x is 2x minus 1 and g is from real to real, g of x is x squared, okay, then then g of f of x is, okay, fine. So g of f of x, this is just 2 times of, oops, this is just f of x squared, which is 2x minus 1 squared, which is 4x squared minus 4x plus 1. That's it. This was, what kind of question was this? Next question. Next question is, if f is a real to real function, x plus 1 squared and g is x squared plus 1, then f of g of minus 3 is, so f of g of minus 3 is, so g of minus 3 is 10, so this is just f of 10, right? Yeah, and f of 10 is 11 squared, which is just 121. That's it. This was a very easy one. Which of the following functions is invertible? So f of x equal to 2 power x, yes, there already exists a thing which is natural law of, sorry, log base 2 of 2 power x. So yes, this is an invertible function, because this is, wait, this is not exactly a bijection. Yeah, we don't exactly need a bijection for it to be invertible. It could be, yeah, it just needs to be something like a 1-to-1 function, right? An injection. Whatever, this is definitely invertible, because if you have 2 power x equal to y, first of all, it's a 1-to-1 function. So whatever value of y you get, that being 1-to-1 ensures that only for one value of x you can get that value of y. So if you do apply the inverse on both sides, that value of x you get will be like a specific value. You won't get two values at the same time. So that's nice. Okay, and yeah, so if 2 power x is y, we can always find out what that x value will be. So therefore this is actually an invertible function, because we can just do a reverse mapping and it will work. Okay, so this is an invertible function. Then you have x cubed minus x. So x cubed minus x has 3 zeros, so no, it's not a 1-to-1 function. So at least at the point 0 it's not invertible, right? At the point 0, which means like at the point at which y equals to 0, which is actually 3 points. So whenever y is 0, for that 0 value, this is not invertible. So no, this is not invertible everywhere. Then you have x squared. No, this is also not an invertible function, because yeah, this is not a 1-1 function. So I guess the main thing which should be in invertible functions is like they should be 1-1, because yeah, I mean, otherwise the reverse thing, the inverse function, that will not be a function, that will, yeah, it will have more than 2 outcomes, which is not good. Okay, Next question. If g of x is x squared plus x minus 2 and half of g of f of x is 2x squared minus 5x plus 2, then f inverse of x is equal to, oh, so we don't know what f really is. Okay, just put this into g and then half that, so it's like um, f of x squared plus f of x minus 2, this is equal to 4x squared minus 10x plus 4, right? That's what they mean by that. Okay, and now we just need to find what is f inverse of x equal to. So okay, fine, which means f of x squared, just make this thing like that. Okay, plus f of x, just hope this turns out to be something like a square. Okay, minus 4x squared plus 10x and minus 6 equal to 0. This is not looking good. Are there any squares over here? Okay, let's just try making a square. So f of x plus 1 by 2 squared. This is not a good idea. This is not a good idea. This is not nice. So then what is f inverse of x? We could use the quadratic formula maybe. Who knows? Let's try doing that. Yes, let's try. So that means, okay, then f inverse of x is, okay, so f of x is going to be minus b, which is minus 1 plus or minus square root of b squared, which is 1 squared is 1, minus 4ac, so plus 16x squared plus 4, okay, minus 40x plus 24. Okay, nice. I think this might be a square. Is this like factorizable? It looks like that. It looks like that. 4x squared plus, let's try to factorize this thing first, like minus 2 into 2x squared plus 5x minus 3. I don't know how this is working. Okay, this is plus 3, this is minus over there. Minus 2 into 2x squared minus 2x. I've never seen this kind of question before, so it's a very new thing. So this is 2x minus 3 into x minus 1. Okay, so we can write this as 2x minus 3 into minus 2x plus 2. Yes, that's nice, that's very nice. So now we have two roots whose product is this thing, right, and whose negative additions, like their addition is minus 1 and negative of that thing is this thing. Okay, so we know that f of x can be these two things only. So this is 2x minus 3, or f of x is minus 2x plus 2. Nice. And minus 2x plus 2 is not here, so just go for 2x plus 3. Nice, really nice. This is a very new thing. Okay, next question. If f of y equal to y upon square root of 1 minus y squared, and g of y equal to y upon 1 plus y squared, then f of g of y is equal to, okay, so f of g of y is y upon square root of 1 plus y squared upon the square root of 1 minus y squared, right? So this is this thing squared, so y squared upon 1 plus y squared. Wow, y upon square root of 1 plus y squared upon, this should be square root of 1 upon 1 plus y squared, and then this thing just cancels, so you just get y. So it's just y, that's it. Nice. It's like, okay, so maybe f is g inverse, or g is f inverse, who knows. Next question. Next question is, if f of x equal to 2x minus 3 upon x minus 2, then f of x equals no big deal. So it's 2 into 2x minus 3 upon x minus 2 minus 3 upon x, which is 2x minus 3 upon x minus 2, right? Minus 2. So it's going to be 4x minus 6 minus 3x plus 6, okay, upon 2x minus 3 minus 2x plus 4, just x upon, this is cancelled, x upon 1, it's just x. So this is another inverse function thing. Next question, suppose that g of x is 1 plus square root of x and f of g of x is 3 plus 2 square root of x plus x, then f of x is, okay. So you mean like f of 1 plus square root of x is 3 plus 2 square root of x plus x. That is weird. Let's try maybe making this into this thing. So like this is going to be equal to square root of x plus 1 squared plus 2, isn't it? Right? So let's call this thing u. So you just get f of u. F of g sounds much better. So f of g is just g squared plus 2. That's it. That's really nice. So f of x is x squared plus 2. No big deal. Next question. Next question is, if f of x equal to x upon 2x minus 1, then the domain of f of x is, okay, the domain of that thing, right? So what's the domain of this thing? It's just x is not equal to 1 by 2, okay. So you cannot have x equal to 1 by 2, and f of x is going to be this thing, so x upon 2x minus 1 upon 2 times of this thing, so 2x upon 2x minus 1 minus 1, which is x upon 2x minus 1 upon 1 upon 2x minus 1, cancels because it's obviously not 0, so it's just x. So no, this is defined most of the times when this happens, right? So this is almost all the time defined, no big deal. Yeah, next we need f of x, which is once again just x upon 2x minus 1, because this thing is just x. So that's nice. So the domain of this thing is really just r minus 1 by 2. If it's not 1 by 2 or anything else, yeah, if it's not 1 by 2 and it's anything else, all stages will be very, very nice, because everything will be defined. There won't be a not defined thing in any stage. Nice. Because if this is not 1 by 2, then f of x is defined, yes. If it's not 1 by 2, then f of x is this thing, and each part is individually defined. Also, this thing can never be 0, right? Because it just turns out to be 1 upon 2x minus 1, and this thing is like defined and not 0, nothing bad. Yes, so this just turns out to be x. Nice. And then yeah, like, okay, cool. Yeah, next question. If f of x equal to 2x plus 1 upon 3x minus 2, then f of 2 is, okay, so first of all, what is f of 2? F of 2 is just 4 plus 1 is 5 upon minus 2, which is 4, and f of 2 is, just put that over there, this should be 5 by 2 plus 1 upon 15 by 4 minus 2. Is this correct? Yeah, this is correct. So this should be 7 by 2 upon 7 by 4, which is 2. So this should be 2. What's f of x in general? I'll just try to find that out as well. I don't think it's a big deal. Yeah, this will do. Next question. if f is going from real to real and g is also going from real to real are given by f of x equal to mod x and g of x equal to integer part of x for each x is a real number, then okay, for all x real numbers, g of f of x is less than or equal to f of g of x. Oh, so the set of all x such that this equation, sorry, this inequality is true, what is that set going to be? That's what they're asking, I guess. Okay, yeah, so g of f of x is just like integer part of mod of x is less than or equal to mod of integer part of x. Ouch. Okay, so how do we do it? uh, Integer part of mod of x, maybe let's just start by making some cases. Yeah, so case 1, x is bigger than or equal to 0, so that means it's just integer part of x is less than or equal to, so integer part of x is also going to be bigger than or equal to 0, obviously. So it's just integer part of x, and yes, this is obviously true every time. And then you got case 2 where x is less than or equal to 0, which means integer part of x, so it should be just less than 0. So integer part of x is less than or equal to -1. In other words, it's also a negative quantity. So this thing is going to be like negative integer part of x, and this thing is just going to be integer part of negative x. Oh, so this is a little different. Okay, so it is less than or equal to negative integer part of x. Okay, so how do we do this? This looks a little weird. Okay, let's maybe replace x by negative u. So this is like integer part of u is less than or equal to, okay, this is not a good idea. How do we do this now? Maybe let's just try putting in some things, like for example negative 1 point something is this less than or equal to negative of the same thing, 1 point something. Yeah, is this going to be happening? So the integer part of 1 point something, that's 1. Okay, so it's less than or equal to negative 1, and this thing is negative 2. You know what, let's go with that. Let's say x is something like some integer plus some fractional part, say f. So negative integer n minus f is equal to negative of n plus f. Okay, that's nice, which means negative n, and this fractional part should always come out to be positive, so negative n, negative f plus 1 minus f. Okay, so the integer part of this thing, n plus f, it is just n. Okay, nice. And the integer part of this thing, n minus, okay, so negative n plus 1, right? This is some integer. Negative and negative 1 was better, I don't know. So it's negative and negative 1, so it's just negative and negative 1 plus the integer part of 1 minus f, and guess what, 1 minus f is another fractional number, so this is going to be 0. Nice. I mean, this is not 0 if f is 0. So if f is not 0, f is not equal to 0, then you will have that this number is a fractional number. Yes, so this is going to be 0. Yeah, I think that's correct. So this is going to be less than or equal to negative n. Yes, that's correct, because negative 1 is less than 0. That thing is nice. So this case is correct, that if f is not equal to 0, so this is actually a something like 1 point something, so then this is going to work. Okay, uh, what if f is equal to 0? So like you just put an integer into this. So if x is an integer, a negative integer, say x is negative k, then this inequality just becomes uh, integer part of k is less than or equal to so this is just minus k, which means k is less than or equal to k. Yes, that's obviously correct. So even then this does work. So actually for all real numbers it's gonna work. That's nice, that's really nice. So it is all real numbers. Yeah. Next question. If f is a function going from 1 to infinity to 1 to infinity, okay, and it's defined by 3 power x into x minus 2, okay, then f inverse of x, wait, what, no, x into x minus 2 is a many one function, so this is also a many one function, right? Is it? Okay, so x into x minus 2 got 0 and 2 over here. Over here it's like positive and increasing, right? Over here it is positive and increasing, and at one value it reaches its minimum point, so from here onwards it's always increasing. So yeah, for this for this thing it's always going to be an increasing function. So for this particular range, it's good to use this thing as a one-to-one function. Okay, then f inverse of x is equal to, okay, cool. So the first thing we're gonna do is say x minus 1 is something like u. Why? Because that's going to what should I say, maybe let's just do this. First of all, let's just do this because x minus 1 is just going to be a positive value which can also reach 0, right? So it's something which is bigger than or equal to 0, not exactly bigger than 0, so we have more control on it, but whatever, let's just do this thing. So it's like x is this thing plus 1, so 3 into mu plus 1 into mu minus 1. Okay, I thought it would be better. Okay, fine. This thing is y, so mu squared minus 1, and mu is always going to be a positive thing. It's always going to be a positive thing. That's nice. So mu squared minus 1 is just log base 3 of y. So mu squared is just log base 3 of y plus 1, and as mu is always a positive thing, you just get this thing, square root of log base 3 y plus 1, and now we can replace mu by x minus 1. So x is going to be 1 plus square root of log base 3 y plus 1, right? That's nice. I guess we could have also done this by the x thing, but let it be. Yeah, let it be. Okay, so where is this option? B. Let's go to the next question. It's the last question, I think. 60. Yes, if the function, yeah, it should be the last question. Yes, it's the last question. Okay, if the function from real numbers to real numbers be such that f of x equal to x minus, is this an integer part? Yes. Okay, then f inverse of x is, okay, x minus integer part of x equal to y, basically fractional part of x equal to y. It's then or equal to y. Okay, then what is y? Okay, what is x? Wait a second. No, we cannot find this. This is not defined because fractional part of x is like a periodic function, and thus it's not a one function. It's a many one function. So you cannot have an inverse on a many one function, right? This is not defined. This was easy. Okay, so we are done, and I will see you in the next video. Bye.